The dinosaurs went extinct 66 million years ago. In 1990, a book named Jurassic Park was published by Michael Crichton, and in 1993, the movie Jurassic Park was released. This movie was written by Michael Crichton and David Koepp, directed by Steven Spielberg, and is considered to be one of the greatest summer blockbusters of all time. In Jurassic Park, dinosaur cloning was done by extracting DNA from prehistoric mosquitoes that were preserved in amber. The DNA from other animals were used to fill the gaps in the dinosaur's genome. But is this actually possible in real life? Several animals have been brought back from the brink of extinction due to genetic engineering. Many people were wondering if it was possible to bring back dinosaurs, reptiles that have been extinct for 66 million years. Some people assume that since birds are descendants of dinosaurs, birds could just naturally evolve back into non-avian dinosaurs. But this is impossible because there are no evolutionary pressures or mechanisms that would allow them to do so. For most extinct species, scientists could hypothetically bring them back using DNA extraction and cloning. The first step of this process would be to extract DNA. Unfortunately, DNA degrades over time, and even the DNA found in permafrost would degrade significantly within a million years. Since the dinosaurs died out 66 million years ago, there is no viable dinosaur DNA left on Earth. If undegraded dinosaur DNA could somehow be found, it would have to be complete and intact in order for cloning to happen. Lastly, there would have to be a viable surrogate for the dinosaur embryos. However, with future technology, some scientists believe that the idea of creating dinosaur-like creatures is actually possible. The first way is to manipulate bird genes. This is because modern birds are descendants of dinosaurs, and according to molecular analysis, the T-Rex protein fragments are most similar to chicken protein. Scientists might be able to manipulate bird DNA to make them express ancestral traits. For example, at Yale University, the dormant genes in chickens were reactivated to form a snout-like structure that is similar to that of an Allosaurus. The second way is to extract DNA from a species that recently went extinct that's closely related to the dinosaurs, which could create dinosaur-like creatures. So far, I've only talked about land dinosaurs, but what about aquatic dinosaurs like the plesiosaur or the mosasaur? Unfortunately, the same problems apply to these species too, since there's a lack of viable DNA that hasn't degraded, and the lack of surrogates for the embryo. Hypothetically, if we bring back these large aquatic species, would they have a chance of survival? Since Earth's oceans have many resources for these aquatic species to thrive on, you might assume that these species would survive in modern-day oceans. However, the situation is much more complicated than that. A good example of this would be the megalodon. A large shark species lived approximately 23 to 3.6 million years ago. The main reason to why the megalodon went extinct was because of climate change, the lack of prey, and competition. Likewise, if we bring back the plesiosaurs or the mosasaur, they would certainly experience competition with apex predators like killer whales or great white sharks. Let's return back to land dinosaurs. Let's assume that we could genetically modify a reptile or bird species and turn it into a dinosaur-like creature in the near future. Where would we put them? The most logical answer would be sanctuaries or wildlife centers. There would have to be a lot of funding involved to ensure that the dinosaurs are well protected and well fed in their sanctuaries. They would have to be separated based on diets. Carnivores should have their own habitat and be fed a sufficient amount of meat. Omnivores should also have their own habitat since they eat both plants and meat. However, herbivores can live in the same sanctuary as long as there are enough resources to prevent competition. After the dinosaur population grows to a large enough amount to no longer be considered endangered, the non-dangerous species could potentially be released into the wild or natural parks. However, dangerous species like the T-Rex should be kept in an enclosure, as well as other apex predators. Lastly, we need to know how much it would impact the food web. For example, in a rainforest ecosystem, a jaguar or an eagle would be the apex predators of the food web. However, if large carnivorous dinosaurs were introduced, they would most likely eat the jaguars or eagles, becoming the new apex predators. However, small species would be able to adapt to the situation and prevent themselves from bringing the dinosaurs prey. A similar situation happened when dinosaurs still existed. Mammals were at the bottom of the food chain, but since they were small, they were able to survive from the dinosaurs. This was also the reason why they were able to survive the Cretaceous-Paleogene extinction event, since they were small and could adapt to the situation easily. In conclusion, with the current technology we have, it is impossible to bring back a true dinosaur. However, we can modify the genes of currently existing species that descend from dinosaurs or are related to them. Hypothetically, if we did bring back dinosaurs, we would have to spend a lot of money protecting them and studying them to analyze the impact they would have on ecosystems. I hope you enjoyed this video. Please consider liking, subscribing, and commenting on this video to give me feedback. Thank you for watching.